Hi everybody, today we're going to talk about quadratic equations, and this is a big topic, so I've split it into two videos. The first video will cover solving by factoring and using the square root method. Then in the second video I'll build on that. We'll do completing the square and the quadratic equation. So to start off, we need to say, well, what is a quadratic equation? A quadratic equation can be written in the form ax squared plus bx plus c equals 0. A, b, and c are real numbers, and a can't be 0. I need to have that x squared. This phrase in the form is really important because what it means is when we first look at an equation, we may not see ax squared plus bx plus c. But we can rearrange the equation and get it into this form. So that's what that in the form means. It kind of means that math is sneaky. Just because it doesn't look like a quadratic doesn't mean that it isn't a quadratic. So let's take a look at some problems. We're going to start with the zero factor theorem, which says if a times b is 0, then a has to be 0 or b has to be 0. And a and b can be any kind of algebraic expression, so it's not really a number a or a number b, but just these factors a and b. So let's try a couple. So let's start kind of small and say, what if I already have it in factored form? I have x plus 4 times x minus 2 equals 0. So the zero factor theorem says that x plus 4 could be 0, x minus 2 can be 0. So we solve that. I get x is negative 4, and I also get x is 2. Watch for how you're asked to answer questions. A lot of times you'll be told to enter the answers with a comma in between. It really doesn't matter which one you say first. It's just we have these two solutions. Other times you might see a solution set where we put the set brackets around it, but it all means the same thing. So the second one I have is 3x minus 5 times x plus 6 is 0. So again, I'm going to take the factors and set them equal to 0 individually. So 3x minus 5 equals 0 says 3x is 5 and x is 5 over 3. I want to leave it like that. There's a big deal when we do math that we talk about having exact answers. If you put this in your calculator and you get a decimal, well, that decimal isn't accurate if you have to round. So because we would have to round 5 over 3, I just want to leave it as a rational 5 over 3. The second one, x plus 6 is 0, says x equals negative 6. So again, I have two solutions. I'm going to write x is 5 over 3, comma, negative 6. My next one says x times 2x minus 1. So I have x is 0, and I have 2x minus 1 is 0. So the x is 0 is finished. I don't have anything to move. The 2x minus 1 is 0. I make that 2x equals 1. So x is equal to 1/2. Two solutions, 0 and 1/2. Now the next one, I didn't put it in factored form, and it's going to look kind of similar to the other one on this page once I do factor it. So I have two terms, x squared minus 4x, and what I want to think about is what do they have in common? Well, they both have an x, so I'm going to factor that x out. X squared divided by x is x. 4x divided by x is 4. That gives me 0. Kind of what I think about is kind of like once I divide by x, I got rid of one of the x's that were there. So this is not like the perfect form to write it, but see how I kind of went, I got rid of an x, so now I just have x, and I got rid of an x, and it just gives me 4. I want you to like visually see, like I pulled an x out, what did I have left over? So I set those two factors equal to 0. X is 0, x minus 4 is 0. I get 0, and I get 4. So factoring is a really big deal in math. We like to do it. So what you will see the most is these factoring trinomials where I have 3 terms. So I'll talk us through some little hints I can give you about factoring if you need that little refresher. So one thing I look at here is x squared plus 9x plus 18 equals 0. This plus sign. So when the c term is positive, I know both of the factors will have the same sign, which will be what's in front of the b. So I'll have x plus and I'll have x plus. I think about factors of 18 that add up to 9. If you need to, you can always write 18 is 1 and 18, and it's 2 and 9, and it's 3 and 6, and you just list the factors until hopefully you find 2 that work. So x plus 3, x plus 6 equals 0. Again, order doesn't matter because this is part of multiplication. Multiplication is commutative, so you can write it either way. Once we get the factors, we set them each equal to 0. So x plus 3 is 0, x plus 6 is 0. So x is negative 3, x is negative 6. So my second one, x squared minus 5x plus 6 equals 0. I have this same thing I want to shape. The second one, x squared minus 5x plus 6 is 0. I have the same little clue that because I have a positive in front of the c, both of the factors are going to have a minus sign. So I have x minus and x minus equals 0. So this time when I list the factors of 6, they're both going to be negative, and when I add them, they're going to add up to negative 5. So I can think of 6 as like negative 1 and negative 6, or maybe negative 2 and negative 3. And just be careful. I found that this one is something that people make a mistake on all the time, because if you think about it, 6 minus 1 is 5, and so you're like, oh, those are the two that work, but it's not. You have to use negative 2 and negative 3. So careful sometimes. Things that look too easy sometimes are too easy. You just got to slow down a little bit. So this says x minus 2 is 0. This says x minus 3 is 0. I get x equals 2. I get x equals 3. And hopefully you're starting to see this pattern that I have two solutions, and that is generally what's going to happen. Power 2 for my quadratic, two solutions for my equation. So these next one are a little different because I have x squared minus 9x minus 36. So now this minus sign says my two factors are not going to have the same sign. I'll have 1 plus and 1 minus. When you're looking at your factors of 36, and again, I like to write them until you're like really comfortable with them and they like jump in your head. So I start writing 1 and 36, 2 and 18, 3 and 12, 4 and 9, right? So that's more than enough because 3 and 12 is my answer. What I'm looking for is when I subtract. So this negative in front of 36 says I'm going to subtract these two numbers. So 12 minus 3 gives me 9. Subtract the smaller from the larger. What you want to do is pay attention to the sign in front of the b term, and that's going to go with the bigger number. So the minus sign says 12 will be negative, and the 3 will be positive. That way, 3 times negative 12 is negative 36, but negative 12 plus 3 is negative 9. Now I set those equal to 0. X plus 3 is 0, x minus 12 is 0, x is negative 3, x is positive 12. X squared plus 4x equals 45. I can tell it's quadratic, it's x squared, but it's not in the form we want. What we want to do, if we're going to factor, is have this set equal to 0. So quickly, we can just move the 45 over to the left. So I have x squared plus 4x minus 45 equals 0. So I look at factors of 45, and they need to have a difference of 4. I know I'm going to have 1 plus and 1 minus, because this sign in front of the 45 is negative. So again, if you want to write factors, 1 and 45, 3 and 15, 5 and 9, that's where I can stop. Now this time, the 9 minus 5 is 4, that's what I want, but I want 9 to be positive because it's the bigger of the two numbers and it needs to match the sign of the b term, and then I will subtract 5. So this says x plus 9 is 0, x minus 5 is 0, x is negative 9, x is positive 5. So let's try that again. Make sure we understand what we're supposed to do each time before we just make this even bigger. So I have x squared plus 3x plus 54. First thing we're going to do is bring everything to the left. So I have x squared minus 3x minus 54. So we're going to think that we need to factor this. Because the minus is in front of the 54, I know I have 1 plus and 1 minus in my factoring. If I think about factors of 54 that give me 3, it's going to be 9 and 6. Then 9 goes with the negative because 3 is negative, and then the 6 goes with the positive. Hopefully you're starting to see that the terms just flip signs. So maybe you can make that jump. Instead of saying x plus 6 equals 0, you can go straight to x is negative 6. So x minus 9 is 0, go straight to x equals 9. If you need to write the step, write the step. But if you can start to make the jump, it'll help you get through your homework a little faster. My next one says x times x minus 2 is 2x plus 5. So it doesn't at all look like it's a quadratic, but let's do some steps to see that it is. So I'm first going to distribute the x through the x minus 2. So I have x squared minus 2x is 2x plus 5. I'm going to bring everything to the left. I have x squared minus 4x minus 5 is 0. Again, this negative in front of 5 says I have an x plus and I have an x minus. The only factors of 5 are 5 and 1, so I'm going to do minus 5 plus 1. which says x is -1, x is +5. So let's make that even bigger by putting a coefficient in front of the x squared term. So I have 4x squared plus 3x minus 1 is 0. And we can talk through this a couple of ways, and I'll show you what I think about when I see these. One thing that we talk about is the AC method. So the AC method says take the A term, take the C term, multiply them together. So 4 times -1 is -4. And then look for factors of this AC that add up to B. So if I look at -4, I think if I do 4 times -1, that gives me -4, but 4 plus -1 gives me +3. So what we're going to do is we're going to keep the 4x squared. And since 3 is equal to 4 plus -1, we're going to write plus 4x minus x minus 1 is 0. So you can still see 4x minus x is still 3. We're just changing the look of this particular equation. Now I'm going to do something called factoring by grouping. So I'm going to take the first two terms, put them together. I'm going to take the second two terms, put them together. When I look at 4x squared plus 4x, I notice, well, they both have a 4, they both have an x. When I take that out, I get x plus 1. When I look at -x minus 1, they have a -1 in common. I'm going to take that out, and again, I get x plus 1. It's not a coincidence that both of the terms now have an x plus 1. So since that's in common, take it out. And then what's left? 4x minus 1. So we were able to find the factors, but we just had to do a little bit of extra step to get there. So now that I have x plus 1 times 4x minus 1 is 0. I know x is -1. There's one answer. Then 4x minus 1 is 0, says 4x is 1, so x is 1/4. So here are my two solutions. So we can do the same thing with the 6x squared minus 11x minus 10 equals 0. And I will tell you, the first thing I always look to do is think, can I factor anything out? Could I divide everything by 6 or by 2 or by something that makes this really nice? And I only do that is if when I divide, I get integers back. So 6x squared minus 11x minus 10, I can't divide everything by 6 or by 2, so I'm like, okay. So this time, let's just go to the AC method. So I'm going to do 6 times -10 is -60. And I am going to look for factors of -60 that give me -11. If you want, when you first start writing factors, you can just write them both as positive, and then we can fix the sign in a minute. So 1 times 60, 2 times 30, 3 times 20, 4 times 15, and I'm going to stop because 15 minus 4 is 11. And that's where I can throw the negative in to say it needs to be -15 plus 4. That way it comes out to -11. So I'm going to write 6x squared plus 4x minus 15x minus 10 equals 0. If you're worried about, does it matter if I write 4 and then -15 or -15 and 4? And the answer is no, you're always going to get the same answer. It may have little steps that look different if two people were doing it like with a different order, but you're still going to get the same answer at the end. So let's take these 2 by 2 again. So 6x squared plus 4x. Well, I notice they're both even, so let's take out a 2, and they both have an x. 2 goes into 6 3 times. I could drop a power of x. 2 goes into 4 2 times. That x is outside. The minus 15x minus 10, I'm going to take out a -5. -5 goes into -15x. That's 3x times. -5 divided into -10 is +2. And it should always work then that these match. If we're going to be able to factor by grouping, it has to be that when I group it, I have a common term. So it's kind of a special case. It doesn't always work, but in this section, you're going to get things that it does work for. So let's take that 3x plus 2 out. Then I have 2x minus 5. So let's shortcut it a little. This says 3x is -2. So x is -2 over 3. Sorry, this is so close to the bottom. Then I have 2x equals +5. X is 5 over 2. So there are my two solutions. So let's try a couple more. This one says 8x squared plus 10x plus 3. So my first thought is 8 times 3 is 24. Factors of 24 that add up to 10 would be 6 and 4. And this time they're both positive because it says plus 10x. So let's write 8x squared plus 6x plus 4x plus 3 equals 0. So first two terms, second two terms. 8x squared and 6x have a 2x in common. 2 goes into 8 4 times. X goes into x squared x times. 2 goes into 6 3 times, and that x is already outside. Now, I like that this worked out this way because you look at 4x plus 3 and you're like, what do they have in common? And it looks like nothing. But you can always factor out a 1, right? It won't change anything, but it does kind of show what was their greatest common factor, and it's just 1, so let's write that outside and have 4x plus 3. Now I have 4x plus 3 and 4x plus 3. We kind of expected that. We take the 4x plus 3 out, and I get 2x plus 1. So I say 4x is negative 3, x is negative 3 over 4, there's solution 1. 2x is negative 1, x is negative 1/2, there is solution 2. Now this next one, notice it says 3x squared minus 15x. There is no c term. So that says you don't have to do an AC method if there's no c to begin with. So what you do instead is you say, what do they have in common? So they both are divisible by 3. They're both divisible by x. I get x minus 5. This says 3x is 0. If you divide by 3, you still get 0. That's kind of important. And then x minus 5 is 0. You get x is 5. I want you to start seeing this, that having a number times x set equal to 0 just means that x is 0. So it's kind of something you want to be aware of. It's going to be helpful as we grow this and make it much bigger, and we're not doing quadratics, but something maybe much higher. So we're ready to move to our second method, which is called the square root method. And what we want to think about here is if x squared is equal to a, then x is equal to plus or minus a. Let me show you a quick why, because I think this is often confusing for students. So sometimes we'll give you something like the square root of 9 and we say it's 3. But if we say x squared equals 9, when we take the square root, we say x is equal to plus or minus 3. The reason why that happens is because if I have x squared equals 9, that means I have x squared minus 9 is 0. This is the difference of two squares. So maybe you remember we have this format that it would be x plus 3, x minus 3. So factors of negative 9 that come out to be 0 would be positive 3 and negative 3. When I multiply 3 times negative 3, I get negative 9. When I add 3 to negative 3, I get 0. So this is why I have negative 3 as an answer and positive 3 as an answer. So there's a big difference between x squared equals 9, has two solutions, versus if I take the square root of 9, it only has one solution. I know I've already added a lot to this screen, so let me erase it and give you a little reminder. I want to remind you that x plus a times x minus a is x squared minus a squared. So that's a nice little factoring the difference of squares. You might find that really useful as you're going throughout the semester. All right, so let's use that. Let's solve some equations using the square root method. So this says 2x squared is equal to 18. So my first step is divide by 2. I'm trying to isolate the x squared. So x squared is 9. Take the square root, x is equal to plus or minus 3. I like the square root method. It's really quick, it's efficient, but it only works sometimes. What you should notice is there is no b term. There's no plus bx in these, and that's why we get to use the square root method. So 4x squared plus 5 is 29. I'm going to start by moving the 5. Again, trying to isolate x squared. So I have 4x squared equals 24. Let's divide by 4. So x squared is equal to 6. Take the square root, x is equal to plus or minus the square root of 6. Leave it like that. Remember earlier I talked about exact answers. This is an exact answer. This is what I want you to write. So now I have x plus 3 squared is 16. Notice I have this x plus 3 is my square term. So I don't want to expand it. I want to say, okay, I have the square term. How do I get rid of a square? I take the square root. So I'm going to take the square root of the left, the square root of the right. On the left, I get x plus 3. On the right, I get plus or minus 4. I think this is a good place to separate it and say x plus 3 is 4. X plus 3 is negative 4. Subtract 3, that says x is 1. subtract 3, that says x is negative 7, so 2 solutions. Let's do the same thing with x minus 1 squared is 7. I'm going to take the square root of both sides. I get x minus 1 is plus or minus the square root of 7. Now, last time I got integers, so I split it. This time I don't have an integer, so maybe I'm going to leave it together. I'll show you both ways. The 1 needs to go over, so I have x is equal to 1 plus or minus the square root of 7. That means I have 1 plus the square root of 7, and I have 1 minus the square root of 7. So still 2 solutions. I do want to leave it like this. I don't care if it doesn't look pretty. This is the exact answer to this equation. So just a couple more to make sure we understand what we're doing and just to see how much bigger this can get. So start with square root of both sides. When I have 7x minus 3 squared is 81. I have 7x minus 3. Square root of 81 is plus or minus 9. Because these are integers, I immediately separate it to 7x minus 3 is 9. 7x minus 3 is negative 9. I add 3 over, so 7x is 12. I divide by 7, I get 12 over 7. Same thing on the other side. 7x equals negative 9 plus 3 is negative 6. Divide by 7, I get negative 6 over 7. 2 solutions. This one's a little bit bigger. I have 3 parentheses, x minus 2 squared, then minus 7 equals 182. So order of operations will help you make this like easier and not get fractions before I need them. So I would first move the 7. I have 3 times x minus 2 squared equals 189. Then I want to divide by 3. Divide by 3. This says x minus 2 squared equals 63. Then I take the square root. So x minus 2 is plus or minus the square root of 63. And then we're going to add 2 over. So I have 2 plus or minus the square root of 63. I want you to think about 63 as being 9 times 7. And 9 is a perfect square, so I do want to reduce this. I want to say this is 2 plus or minus the square root of 9. So let's write it this way. Square root of 9 is 3 square root of 7. So here are my 2 answers. So you do want to reduce the radicals when you can. We're trying to get it into the simplest form possible. It may not seem like a big difference, but it really does make it easier as we make things bigger for us to be able to get the solution. So as a reminder, there is a part 2 to this video, and it will cover completing the square and the quadratic formula. I like to do things small and in pieces so that it's not overwhelming. So just give yourself practice. This will come easier as you go, and we will look at quadratics multiple times. So this is not a one-time deal. We're going to graph it and do all kinds of things, do applications, and I think you'll really like it. So good luck.